Mrs. Wally, what are you doing?
We get to take off our masks.
Yay!
Hooray!
Why?
Friends!
Why do we get to take off our masks?
Well, we're both vaccinated.
Mm-hmm. So is Mr. Kevin.
We're being filmed,
Mm-hmm.
and we are more than 6 feet apart.
We are. So we start with our masks on.
Because we're not filming yet.
And then when we start speaking, we can take them off. But then when we're done, they go right back on.
Yep, and they stay on until we film the next episode.
You have a whole mountain between you.
I know. Look at that. Look how beautiful the mountain is.
Beautiful.
That is Mount Rainier, or Mount Tahoma.
Mount Tahoma.
Hi, friends. Welcome back to the TV classroom.
It feels like a Monday.
It sure does feel like a Monday, friends. So we're going to do the best we can with what we've got.
We're going to be patient with ourselves and with each other.
We are. Let's check in with our zones.
Let's do.
I think you probably have a prediction about the zones of the teachers on TV. Miss Oslin, what zone are you in today?
I am physically and emotionally in the green zone.
Oh, that's good.
I'm good to go. I'm well rested. I'm emotionally in the yellow zone.
Yeah.
I'm a little bit anxious just about some unknown things that's kind of making me feel anxious.
Yeah, me too.
Yeah.
I'm feeling the same way.
Okay. Well, we're in it together.
I'm in the green zone mentally. No, emotionally. Huh? I don't know. Mentally, I'm in the green zone.
Okay.
I'm focused.
Good.
Physically, I'm still in the blue zone.
Mm-hmm.
But emotionally, I'm definitely in the yellow zone.
Yeah.
Just waiting.
Just waiting.
I don't like waiting, or what I like to call limbo land.
Ooh.
It's not my. Some people really enjoy like limbo land and like not knowing what's going to happen next. That's not me. I really like predictable things.
Me too.
Mr. Kevin, how are you today?
Well, thank you for asking, teachers. So I'm in the yellow zone as well, and for probably a similar reason to
Yeah.
the two of you. So, but you know, one thing that can help, I read this weekend. If you put a smile on your face,
Well, just pretend.
eventually it changes your mood.
Yeah, probably. It's true. Yeah.
It does. It has something to do with like the muscles in your face, and it triggers a chemical reaction.
It does.
Mm-hmm.
It's true. Or if you're around people who are really happy, that can really boost your mood. I'm not sad. I'm just waiting.
Yeah. Waiting is hard.
Waiting is hard. So, well, let's do our lesson, shall we?
Let's get started.
3 personal standards first.
Today and every day, when we come together, we agree to show respect,
make good decisions, solve problems.
Oh, we are going to continue every day our acknowledgement, honoring our indigenous lands and people.
Now, we got some feedback
We
about
did.
what we were saying and
Yes.
that it wasn't exactly accurate. And so when we know better, we
We
do
do
better.
better.
So see if you can hear what's changed. Ready, kindergartners?
I'm going to invite you to look outside your window if you're able. Look at the sky, look at the trees, look at your surroundings. Our physical space stands on the historical and ancestral lands of the Puyallup tribe of Indians. We acknowledge the Puyallup tribe of Indians community, their elders both past and present, as well as future generations. We make this acknowledgement as part of our work to dismantle the ongoing legacies of settler colonialism and white supremacy. Now, when we do this, we acknowledge that we are on the land of the Puyallup tribe of Indians. And the feedback that we got was that we need to be saying it's the Puyallup
tribe
tribe.
of Indians. Yeah.
So as we move forward for the rest of the school year, we're going to make this acknowledgement. We might make changes again going forward as we get more information. And we're going to talk more about what all of these words mean. What is the ongoing legacy of settler colonialism? What is white supremacy?
What does
Because these
that
are
mean?
important things for us to be talking about.
Because when we know better,
We
we do better. And if we don't know, we can't do better.
It's true. Right. Ooh. The scientific process.
I love the scientific process. You know, Miss Oslin, I've been doing a lot of studying about
Yes.
scientific research
Yes.
and educational research. And this whole thing, it's like the whole thing is all in there.
Yeah.
So it's been really fun to study it.
Yeah, I bet. We don't really start here because
No, first we wonder.
we wonder. It's where
We
we
notice a phenomenon.
make observations, ask questions.
Try to like share ideas and create understanding and do a lot of reading. You might read what scientists have said. You might read what other people have observed. You might read about people's experiments and understand the data.
That's what we're going to do today. We're going to read some scientific text.
It's going to be so fun.
Then we use what we thought we knew and new information to come up with an explanation.
Yeah.
Gather more information, interpret our
It's called
observations.
creating a hypothesis.
Ooh, hypothesis.
We take what we think we know and what we think is true, and then we make a statement about why we think that happens.
And if our new learning changes our thinking, we
get to
revise
change.
what we thought we knew. And that's when our brain
Gross. And we start to actually have experiments and see if our hypothesis is true. Is it true or were we wrong? And did you know that most of the time, scientists are wrong? Most of the time, they're wrong. They do experiments and it doesn't work. So they have to go back and do the process again and again and again. And pretty soon, then they find the right one. Like the people who made the vaccines for COVID.
I was just having the same thought.
They had to try and try and try. But what's really great is it didn't take them many tries before someone figured it out. It was lucky, just luck that one worked. And they found it quickly. And aren't we so grateful? Whew, I'm grateful.
And they revised their thinking when they made a mistake with the dosage.
Yep,
And
they
that's how
did.
they figured out that a couple of our vaccines needed two
Two
doses
doses.
because they made a mistake. So
That's true.
exciting things come out of
And then
mistakes.
as things happen or people have reactions, and they paused and they went back and they looked at the data and they looked at it really carefully to make sure it was still safe for everyone. And then they made their recommendations. They're constantly revising. Same with mask wearing, same with distancing. If you've had a vaccine or not had a vaccine right now, it's kind of confusing because who can and can't wear a mask? Who has to and doesn't have to?
Yeah.
Because we're in this like transition, but pretty soon get back to normal. We just
will.
have to be patient.
Yes. Mr. Kevin, he's been raising his hand. Sorry.
I have a science word question, and I know this may not be a big science word, but what is hypothesis?
Oh, a hypothesis.
Hypothesis.
A hypothesis is when someone notices a phenomenon and they come up with a reason that it's happening. So they make a hypothesis as to why that phenomenon is happening. For example, we went to the slides.
Did.
And our hypothesis was that the longer the slide, the faster you go because of momentum. Now, that's our hypothesis. That's what we think is true. We need to continue to do more research to prove that it's true. So all of the research, all the data you collect, all the experiments prove whether or not the hypothesis is true or untrue. And that's what scientists do.
So it's like an educated guess.
Kind of. Well, that's a prediction. It goes hand in hand with that. Yes.
Okay.
But it's an educated explanation as to why something's happening. Like it's happening that you go faster because of your momentum. We might do research and experiments and find out it actually has nothing to do with momentum. It might have something to do with something else. But it's an explanation for a phenomenon that's happening in science or education or business or between people. Anthropologists, they have lots of hypotheses. Yep.
Thank
There's
you.
different kinds of research you do to validate or invalidate your hypothesis.
Yes. Great question, Mr. Kevin.
Neat.
Great question. It's what Mrs. Wally has been studying in depth for the last 2 weeks.
We can tell because you have a lot of knowledge about it right now.
Yeah, it's
It's all in there.
it's
fresh.
moving around in my head all the time. I have to take a big test on it, so I have to know it really well.
Then, as we learn more, we start to satisfy our curiosity.
We do.
We start to say, oh, that's
why.
And then that always leads to
More questions.
Always, because as
And then-
scientists, we're always getting more curious.
And then we find new phenomenon, and then we have more hypotheses, and then we look at more, and we read more, and we research more, and we test more, and it just goes around and around and around. It never ends.
So, what are we learning about?
How do
do
objects move,
or remain still. Should we review our big science words?
Let's review.
Okay.
Okay. Are you ready?
We're ready.
You ready for...
Oh, friends.
The big science words!
The first word we learned is a force.
A force. A push or a pull on something.
Ooh, I saw lots of friends do that
That
with
was
us.
awesome.
We learned about motion, which is the act of moving.
But we're trying to figure out what makes something have motion. A push or a pull on something.
We call that a force.
So what makes something move or remain still? I think we might be coming up with a good idea. The ramp.
We talked about a ramp when we did our
Experiments.
experiment. A ramp is a flat surface with one end higher than the other. And a slide. A slide is a smooth, sloping track.
And we got to experience those at the Point Defiance slides and stairs.
Yes.
Some people call them the chutes and ladders.
Oh, that's a fun name.
It was pretty cool.
Are you ready for our chant?
I'm ready.
Okay.
Here we go.
Okay, this is Forces Here, Forces There, and it's by the Dry Creek Glad team.
All right, ready?
Yes.
Forces here, forces there. Forces, forces everywhere. Invisible forces pulling downward. Unbalanced forces exerting energy smoothly. Momentous forces creating movement powerfully, like on the slide. And opposite forces influencing predictably.
Ooh, predictably, I like that word.
I do too. Forces around the playground, forces against one another, forces on objects around us, and forces within nature. Forces here, forces there. Forces, forces everywhere. Forces, forces, forces.
Force.
A push or a pull on something. It is the thing that causes an object to move or remain still. Now, when you get into 3rd grade, you're going to learn more about forces and what we call balanced and unbalanced forces. So it gets even cooler.
That's exciting. Okay, let's review our force input chart.
Let's do it. Are we ready?
I'm ready.
We're going to see if it's in the... Oh, look at that.
Look at that.
Perfectly centered.
Beautiful.
High five team. Boom, boom. Awesome. So a force, it can be a push. That moves something away from you.
Oh, a push.
Push.
A pull, a force that moves something towards you. Now it's interesting, when Miss Oslin was at the top of the slide and I was at the bottom of the slide, Miss Oslin used a push to move something away from her, and gravity was exerting a pull to move the ball towards me. It was a push from Miss Oslin and a pull towards me.
Oh, it's all about perspective, huh?
It's all about in relation to you.
That's so interesting.
Then magnetism. We haven't really done this, but you can experiment with magnets at home. It's a force that pulls metals towards the magnet. So it's this special invisible force that pulls metal towards it. It's kind of fun to play with. And then gravity, a force that attracts two objects to each other. And friction, a force that slows or stops motion when objects rub together. Rub your hands together. You can feel that heat. That heat causes what friction is, and it can make something slow down.
So interesting.
Kind of like when you kick a ball on the sidewalk and it can go really far, but then you go in the grass and kick the ball with the same force and it doesn't go as far. The grass is causing friction and slowing the ball down.
So interesting. Okay, now we're going to use everything that we've learned so far. We're going to use our big science words. We're going to use our experience with the slide and the ramp. We're going to use what we've learned from our input chart. We're going to use what we've learned from our chant.
And what we've learned from just our life around us.
Yes, to read a book.
Oh, are you ready? I'm ready. Okay.
This book is called Motion, Push and Pull, Fast and Slow by Darlene Still and illustrated by Cherie Boyd.
Okay. Well, motion. We've been talking about that. That's something moving. A push or a pull, that's a force. And fast or slow is how quickly it moves.
Yes,
I think we can read this book.
I think we can.
Look at that dog.
I know, I thought that the ball was going to hit the dog in the face. I hope the dog catches it.
I hope it's okay.
When we read an informational text.
What's this, Miss Oslin?
This is an informational text feature called a table of contents. And this tells you what you're going to read about in different parts of the book. And it tells you what page number you're going to find it on.
You mean if I don't need to know how things move, but I want to know who's moving, I can just skip it and go to page 18?
That's the beautiful thing about an informational text. You don't have to read it from beginning to end for it to make sense like you do with a fiction text.
You know, I have a friend, and she's an adult now. She just realized she didn't think she used to like informational text. But we were talking, and she said, what I've realized is I get a few informational texts on the same topic, and I'll read one part, and then I'll go see if I can find it in the other books. And I just do like 10 to 15 minutes of reading of it a day, but I'm learning so much, and I actually am really enjoying informational text.
That's something strong readers do, is they read a book, more than one text, or they, or even a video can be a text, right? It doesn't have to be a book. But if you use more than one source to learn about the same thing,
it kind of makes it stay in your brain. And she said she wished she had known that earlier, but she didn't realize it till she was an adult.
well, I'm glad our kindergartners at home are learning it now.
I know.
So we can learn about changing places, how things move. Let's get going. What's moving? And then that's where we can do some experiments, learn some facts, a glossary. That's another text feature that will tell us what words mean. And then there's a to learn more and an index.
What's an index?
An index is another text feature that's often at the back of an informational text, where if you think of a word like force, you can go to the index and it'll tell you what pages in that book you can find that word.
And then the glossary is just the big science words.
Yeah, very interesting.
Well, why don't we start at the beginning of this one?
I think that's a great idea.
Okay.
So another text feature that we're seeing on this page is a heading. The heading is larger, bolder print that tells you what you're going to read about in that section.
Sometimes it's even underlined, but not in this book.
This says changing places. That's the heading. So that tells us we're going to read about changing places,
which I'm kind of curious about.
Should we
Let's
read to
read.
find out? You run to catch the school bus. The bus rolls down the road. Tree branches sway in the breeze. An airplane flies up into the sky. Anything that goes from one place to another is in motion.
You know what I was just thinking? If you're running, chasing the school bus, and the school bus is moving, when the school bus is moved on, you end up where the school bus just was.
Oh, that's interesting.
Changing places.
Changing places.
What's that thing down below?
That's called a fun fact.
It's like
And
a fact box.
it's a little fact box, yeah.
Ooh, those are fun.
I'll
Shall
see
we
if I
read
can
it?
read this. Let me get my good reading eyes. There are all kinds of words to describe motion. You can run, walk, jump, dance, swim, slide, and skate.
Whoa.
Birds soar. Snakes slither.
Ooh, those are some...
Monkeys swing from tree to tree. What other motion words can you think of?
They're adverbs. They're describing emotion.
Because you wouldn't just say, I moved. You would want to say, how did you move?
That actually could even be a verb, too.
What other words can you think of to describe
Glide.
motion?
Gliding through the water.
Trot.
Ooh, yes.
Wiggled.
Wiggled like a worm.
Skip.
Rotate.
That's a good one. I didn't think of that.
When you're going in a circle, you rotate
Yeah.
around.
That makes me think of spin.
And
Oh my goodness.
twirl.
Ooh, twirl. That's a really good one. Can you think of any at home, friends? Take a moment to think. What are some words you would use to describe moving? Take a little think time. Now, get your science journal out. Get Get it out. Get it out. Or a piece of paper, or a whiteboard. Can I have him do something really quick?
Yes, please do.
Okay. On your journal, I want you to write the word move. Ooh. Oh, there's Tippy V. Do you know about Tippy V?
Tell me about Tippy V.
Mr. Kevin, can you show them my journal?
Mm-hmm.
Well, this V, it only is on one point, and if there's nothing after it, it'll fall over.
Oh, we don't want that to happen.
No, so what letter do we have in our alphabet that can be silent? Miss Aslan?
The silent E.
The silent E. So you just put it there, and it just keeps V from tipping over.
Phew.
So sometimes E makes the vowel say its name, and sometimes it protects V from falling over.
Interesting.
Move.
Move.
Now I want you to draw quickly, a sketch, quick. What was what you did? What was your motion word? Are you ready? So I did rotate.
That's a good one.
So I'm gonna have, here's my world. And here's the sun. And it's gonna rotate around the sun. Rotate.
Nice. I like how it's a quick sketch, but I can tell exactly what it is.
Magic key makes A say its name. Rotate.
Rotate.
Did you do it? Okay, good. Okay. Close your pen or put your pencil down. Let's keep reading.
Okay.
Because scientists, they take notes when they read
Yes, they
to
do.
remind themselves. Okay.
There's another heading. How things move.
Oh, well, I know there's a push or a pull. Let's see what they say.
Up and down, forward and backward. Some things move in straight lines. Sideways or around and around. Some things move in curved lines. Ooh. Oh, there's another fun fact. One car travels over a hilly road. Another car travels over a winding road. Both cars are moving in curved lines.
Okay, friends, Miss Oslin, we don't need to see this, Mr. Kevin. We're going to listen to Miss Oslin and we're going to draw lines on the ways things move.
Yes.
Can you say it again?
Shall I reread the fun fact or the text?
The text.
The text. Okay. How things move. Up and down.
Okay, so you make a line going up and down with arrows on either end.
Forward and backward.
Ooh, that's going to be hard. So I'm going to draw a person and they're going to be facing one way. And just a quick sketch, and they can go forward or they can go backward.
Some things move in straight lines. Sideways or around and around.
Or around and around.
Some things move in curved lines.
Like a snake slithering.
Yeah.
Look at all those different motions. Mr. Kevin, can you show them my page? Up and down, forward and backward, straight line, sideways, a curve around and around, and a curved line like a snake.
And the fun fact told me that a car can ride on a curvy road or on a hilly road.
It can go like up and down like this. Woo! That's whole different ways you can move.
But they're both curved lines. That's how they're similar.
Curve like this or up and down curved. Lots of different ways to move. Okay,
A car whizzes down the road. There's another word.
Whiz. Well, that means really fast.
A car whizzes down the road. A baseball crashes through a window. Some things move quickly.
Like me, if my baseball crashed through the window, I might want to feel like I need to hide.
Yeah.
But I probably should knock on the person's door to let them know and say
This happened
sorry.
at our neighbor's house last week.
Oh,
But luckily
no.
it was their own, like the kids through their own window. It wasn't someone else's window. Not luckily.
I have a
it's still
story
not good, but-
about that.
What happened?
My sister was playing with her friend when she was little. My sisters are grown up now. She was little, and they were playing See If You Can Miss the Car. Don't ever play
That's
that game.
not a fun game.
And they were throwing rocks.
I hope they missed.
They broke someone's window, and my sister had to work to pay off
Oh,
the
yeah.
window.
You learned that lesson quickly.
Yeah, it was not. Please don't throw things at people's cars
So the rock was moving quickly.
quickly, and it was very dangerous.
That is dangerous.
She got in really big trouble.
A baby crawls across a room. A ball of yarn unwinds and rolls away. Some things move slowly.
You know, if you try and pull that ball of yarn by the string, you just get a big pile of knotted up yarn. That's not fun.
No. Let's get going. A kick from your foot makes the ball scoot across the field. Stepping on the gas pedal makes the car drive away. Here's a word. Inertia. Say
Inertia.
Inertia is a property of all matter.
It's true.
Inertia won't let things move unless a force is a push or a pull on something, gets them going. A kick is a force that moves a ball. A motor creates the force that moves a car. Interesting. Inertia.
What was the force that got the ball moving on the slide? Miss Oslin, did you push the ball or did you just let it go?
I very intentionally just held my finger on it and then just lifted my finger up.
So what was the force? It was a pull. What force was it?
It's the pull of
Gravity. Pulling it towards Mrs. Wally down the slide using momentum.
Inertia.
I get that reference.
I do too. That's funny, Mr. Kevin.
Your bag slips off your shoulder. What is the force that got it going? Because we know that it won't move unless there's a force. So what is the force if it slips off your shoulder? What makes yo-yos dip and water spill? Oh. Why do baseballs curve down?
It's the same reason the ball went down the slide.
The Earth's gravity is the force, a push or a pull on something that pulls everything down toward the ground.
Because we're on a globe, so some of us are actually hanging upside down depending on which way we are at that moment. So everything's pulling us in towards the center of Earth and holding it all in.
And that's gravity. A rolling ball, a speeding car, and a falling raindrop will keep moving until something stops them. Inertia also makes moving things keep on going. What does that mean?
It means once an object is in motion, it's going to stay in motion unless another force acts on it.
Oh, that's like friction you were talking about kicking the ball on the sidewalk.
Right. If you're in a place that has no friction, it will go forever and ever unless something stops it.
Interesting.
So it stays still until something makes it move, and it moves until something makes it stop.
You need to wear a seatbelt because of inertia.
Yes.
Suppose your car stops suddenly. Your body will keep moving forward until a force stops it. A seatbelt stops your body and keeps you safe.
The seatbelt is the force holding you in. It's a pull. It pulls you into the seat. Or if you're in a harness, or like Oliver is in a car seat and he has all these different clicks, it keeps him really have to tighten it down. That way, when we're moving, he's safe in the car.
The ball you kicked rolls across the grass. As the grass rubs against it, the ball slows down and stops. This rubbing is called friction. Friction is a force that makes things slow down or stop moving. Anything that rubs can cause friction, even air. I've never thought of air as a force. People who design airplanes think a lot about how to keep air from slowing things down.
It's true.
Who's moving? I think this is going to talk about the perspective. Like we talked about a push or a pull depends on whose perspective it is that we're talking about. That's another thing that strong readers do is they read the heading and they think, what am I going to learn about?
And what do I already think I know?
And they make connections. And then as we read, we might have to revise our thinking. Or we say, yep, I thought I knew that.
That's called confirming your thinking.
You are on a moving bus. Some friends outside see you looking out the window and wave. Your friends outside think you are moving very fast. But what about the friend next to you? Does this friend think that you are moving fast? Not at all.
Because they're moving on the train together. you're moving together at the same speed.
Or in the car. It's the same thing, right?
Right, like if you're in the car and you toss a piece of paper up, it just moves with you in the car. It doesn't like, it was still already moving with you, so you keep moving.
Yeah. The world is full of motion you can't sense. Even as you read this book, you are speeding through space. That's like the globe you were talking about. You are on the Earth, and the Earth is spinning around and circling the sun. What's that word you said?
Rotate.
Leaves are fluttering. Oh, that's another good movement word. I can really picture it.
I can too.
Raindrops are falling. Cars are whizzing by.
I would say raindrops are dripping.
Ooh, yeah. Look for motion and the forces that create in everything around you. Are you ready for an experiment?
I am. I have it. Now, friends, you can do this with me at home. If you have a journal or two of the exact same pieces of paper, they have to be two of the same pieces. They can't be different. So I pulled out two pieces of paper from, Mr. Kevin, you don't should do it straight on. So if you want to just have me and Miss Oslin.
Okay.
Two pieces of paper. One of them, I'm going to crumple. One of them is going to stay flat.
Okay.
Okay. So this one, I'm going to drop.
Yep.
You ready? We're going to do it the same height. I can't go very high because I'm
Pay
just going
close
to drop it.
attention to how it falls.
I'll do it again.
Do it one more time, yes.
Ready, friends? Watch
How does it fall?
It floats. Okay, now I take the same paper, crumpled up. Woo! Thud.
Why? It's the same piece of paper. Why did it fall differently?
What do you think at home? Take 1 minute to think about that. I'm going to do it again a few times as you're watching and thinking and listening to think time music. Why do you think that's happening? Okay.
What do you think?
There was a part of the book you read where the airplane was, and it said that air can be friction.
Anything that rubs can cause friction, even air. People who design airplanes think a lot about how to keep the air from slowing things down.
This one is really flat, so the air can like push on it a lot. Air is pushing and like making it float. This one's all crumpled up, so it doesn't have, the air can't really make it move
The
like
flat
that.
sheet has more surface area,
Yeah.
and the crumpled is smaller. It doesn't have as much surface area. Oh,
But did you know in a vacuum, that means you've sucked all the air out? That this and this will just are the same, right?
because there's no friction
There's no
there.
friction. The friction's gone.
And if there's nothing there to stop that motion, they would fall
The same.
forever.
Right. You could do a bowling ball and a feather in a vacuum and they fall at the same speed. Pretty cool, huh?
That would be really cool.
Wouldn't it though?
Okay. We've done a lot of observing and thinking, and now we've done some reading and experimenting about how do
Motion.
objects move
Or
or remain still.
Do you think you can answer that question, friends?
I think so.
Oh, I think so too.
You can also go back and revise your inquiry chart, which is the T chart, where you thought about what you think you know about a force and what you want to know or wonder about forces. And I bet you have some things to change and some questions that you can answer. You probably have more questions too.
And next time, when we do science again, we're going to start putting all of those scientific words together and making really great scientific sentences. I'm so excited.
The people around us are going to be so impressed.
But before we do that, you should take some time to write down the things
Yes.
that you remember, or the words that you remember, or pictures to help you remember what a force is and how objects move or remain still.
You're going to use those words and that new learning to notice the forces all around you. Even if you can't see them, they're there.
You know, we got some balloons today from Miss Larson, and I can see them moving right now. They're kind of like wiggling back
But I
and
don't
forth.
see anything pushing on them.
No, but we do have a fan back here, so I wonder if the air is moving.
We could do a fun experiment.
We could.
We're out of time.
We're out of time.
Okay,
Maybe next time.
kindergartners, we would love for you to send us your thinking here at TV Classroom. We want to know the forces that you see or don't see, but you know they're there
The invisible
all
ones.
around you. Mr. Kevin's going to tell you 2 ways that you can send us your thinking.
2 ways. Yes, 2 ways. Ask your adult to help you, and you can email us at tvclassroom@tacoma.k12.wa.us. You can always mail something in the regular mail to TV Classroom at 601 South 8th Street, Tacoma, Washington, 98405.
Thanks, Mr. Kevin.
Now it's time for our affirmation.
We ask them to notice. So I am observant. That means you observe and notice things around you
Paying attention to what's
really
happening.
closely.
I like that. Okay, let's take a deep breath together and say our affirmation.
I am observant.
Excellent job today, kindergartners. We hope you have a great rest of your day, and we look forward to seeing you back here next time in our TV Classroom.
Bye, friends. See you later.
Rules. 1. You have 10 seconds to pick your crewmate. 2. A new timer will appear with an exercise for the crewmate you picked. 3. You will get points for each correct crewmate and exercise you choose. 4. If you pick the imposter, you will lose all your points. 5. Use your math skills to see how many points you can get. Good luck!